Hello and welcome once again to my chemistry lesson. My name is Mr. Philip Maman. Today I'll be discussing a topic, particulate nature of matter. Students know that matter exists in dual nature, meaning that matter can exist as a particle and matter can always also be wave-like in nature. Today we'll be looking at the particulate nature of matter under the subtopic, the concept of atoms, ions, and molecule. I'm sure you heard me right. The topic is the concept of atom, ions, and molecule. Oftentimes, students confuse these three particles. They confuse the atom for ion and molecule for atom. Today, we'll be clarifying these issues. We start by looking at the definition of an atom. What is an atom? An atom is the smallest particle of an element that can take part in a chemical reaction. Again, an atom is the smallest particle of an element that can take part in a chemical reaction. An atom is made up of three fundamental particles. These fundamental particles are the protons, neutron, and electron. Again, the proton, neutron, and electron. The proton, neutron, and electron can be differentiated using their masses and their charges. That's how you can differentiate the proton, neutron, and the electron. So that let's look at them one after the other. The proton is positively charged and it has a mass of 1. It was discovered by Ernest Rutherford in Goldfield experiment. The electron is negatively charged and it has a mass of 1 all over 1860. It's referred to be negligible in some parlance because the value is very minute. J.J. Thomson discovered the electron in the cathode ray tube experiment. The neutron has no charge but it has a mass of 1 and it was discovered by James Chadwick in radioactive decay experiment. Remember again, proton is positively charged with a mass of 1, electron is negatively charged with a mass of 1 all over 1860, which is said to be negligible, and the neutron has no charge or have a charge of 0 but a mass of 1. Now, these scientists have helped in this discovery and they have done very well in sciences. I'm sure that you must have come across their name in one aspect of chemistry or the other. As we can see, J.J. Thomson, an English physicist, discovered electron in the year 1897. Eugen Gunsten, a German, discovered positive particles in 1898. Ernest Rutherford, a New Zealander born British, discovered proton and nucleus in 1911. And James Chadwick, an English, discovered neutron in the year 1932. These are the discoveries that these scientists have made. We'll be moving further to look at the structure of an atom. How does an atom look like? Many scientists have tried to describe the structure of an atom, but the one that we are discussing today is the one by Niels Bohr. Niels Bohr saw an atom as an atom is made up of a central located nucleus which contains the proton and the nucleus, which is surrounded by electrons in orbit. Again, the atom is made up of a centrally located nucleus containing the proton and the neutron surrounded by electron in orbit. When we say what is an orbit, another name for orbit is orbital. An orbital is a region in space where there is the highest probability of finding an electron, meaning that if there is any probability of finding an electron in an atom, it will be found in the orbital. The orbital can also be called shell or energy level as the case might be. My wonderful student, I would like to draw your attention to very important fact, and this fact is the fact that an atom is electrically neutral. And why is the atom electrically neutral? Because the number of protons are equal to the number of electrons. Again, atom is electrically neutral because the numbers of protons are equal to the number of electrons. Now, all atoms are made up of these three fundamental particles except hydrogen. Of course, hydrogen has only proton and electron, meaning that hydrogen has atomic mass of 1 and atomic number of 1. As you move forward, you will get to understand what atomic mass means, and what I have said will have a clear meaning in your own thinking. My wonderful student, let's look at the next aspect of our discussion, which are two very important numbers that you find in an atom. Anytime you see an atom, for instance an atom with a symbol X, there are two very distinct numbers that are always on the atom, and these numbers are your A, which is atomic mass, and your Z, which is atomic number. As you can see in the case of calcium here, A is 40 and Z is 20. Now we get to find out what these numbers represent. What is atomic mass and what is atomic number? Atomic mass or atomic number is the total number of protons only in an atom. Again, atomic number is the total number of protons only in an atom. I said earlier on that in an atom, the number of proton is equal to the number of electron. So if you say atomic number is the number of electron in an atom, you are not far from it. What about atomic mass? Atomic mass is the total number of protons and neutrons in the nucleus of an atom. Again, atomic mass is the total number of protons and neutrons in the nucleus of an atom. Now we can find the number of proton and the number of electron. What about the number of neutron? How can we get our number of neutron? Your number of neutron you can get by subtracting atomic number from atomic mass. If you subtract atomic number Z from atomic mass A, you will get your number of neutron. Remember, atomic mass is also called mass number. So if you hear mass number, don't get confused. Again, your number of neutron is atomic mass or mass number minus atomic number. My wonderful student, let's take an example of what we have said so far. For instance, let's look at the atom of chlorine. If we look at the atom of chlorine, you will see that there are two atoms of chlorine. One of them have atomic mass of 35, the other have atomic mass of 37. But of course, both of them has atomic number of 17. So the number of proton is equal to 17. The number of electron is also equal to 17. But the number of neutron is A minus Z, which is 35 minus 17 for the first case, which is equal to 18. Or on the other case, which is atomic number is 17, electron is also 17, proton is 17, but number of neutron is 37 minus 17, which is equal to 20. In whatever case you have, when you are given an atom to find the number of proton or number of electron, I'm sure you'll be able to do justice to it. Now we have seen two different atoms of chlorine having the same atomic number but different atomic mass. That brings us to our next discussion, which is isotopy and isotope. What is isotopy? Isotopy is a phenomenon, existence or occurrence of atoms of the same element having the same atomic number but different atomic mass, and they are called isotopes. Again, isotopy is a phenomenon, existence or occurrence of atoms of the same element having the same atomic number but different atomic mass, and they are called isotopes. Then isotopes are atoms of the same element having the same atomic number but different atomic mass. Now the difference in the atomic mass is due to the difference in number of neutrons, as we saw displayed earlier on. In one of the chlorine atom, we had 18 neutron. In the other one, we had 20 neutron. And that's responsible for atomic mass 35 and 37 differences. Now let's take a look at other examples of isotopes. Examples are, as you can see, chlorine, we can see carbon. Chlorine 35 and chlorine 37. Then we have carbon 12 and carbon 13. There are so many other examples out there that you can lay your hands on, and if you do, you'll be doing justice to this topic, as I have said. My wonderful student, let's look at what an ion is. What is an ion? An ion or ions are atoms or group of atoms that carry electric charges. Hello? When you say ion, ion is not electrically neutral. It carries electric charge, and that's why ions are atoms or group of atoms that carry electric charges. When you have group of atoms that carry electric charges, they are also called radicals. So a radical is a group of atoms that behave as one unit. In most cases, they carry charges, or in all cases, they carry charges. There are two types of ions, namely cations and anions. Cations are positively charged ions, that move towards the cathode during electrolysis, and that's why they are called cathode ions. The short form of cathode ion is what we call cations. Remember, cations have more protons than electrons, and that is why they carry a positive charge, showing that they have more protons than electrons. Now, what about anions? Anions are negatively charged ions that move towards the anode during electrolysis. They are called anode ions. The short form of anode ion is anions. Anions have more electrons than protons. Again, anions have more electrons than protons. That is why they are negatively charged. Now let's take a look at examples of cations and anions. If you take a look at this, you will see that sodium carries a positive charge, meaning that sodium has atomic number of 11, meaning that it has 11 proton. But in this case, the number of electron is one less than proton, so the number of electron is 10. Again, sodium has 11 protons but 10 electrons. But in the case of chlorine, chlorine has atomic number of 17, but because it has one electron more than the number of proton, the number of proton is 17 and number of electron is 18. My wonderful student, you must know that atoms ions are carrying the electronic configuration of noble gases. My wonderful student, if you look at the screen, you will have seen different type of ions. You have hydrogen positive, sodium positive, potassium positive, ammonium positive, then you have OH negative, chlorine negative, triiodonitrate 5 negative, and so on and so forth. I know that you will lay your hands on other authorities and you'll be able to say more about ions. As we move further, we'll be looking at the next concept, and the next concept is the concept of a molecule. Yes, molecule. Remember, we have said an atom is the smallest particle of an element that can take part in a chemical reaction. We say an ion is an atom that carry electric charges, or an ion are a group of atoms that carry electric charges. Now we'll be talking about a molecule. What is a molecule? A molecule is the smallest particle of a substance that can exist independently. Very important, can exist independently. Another name for independently is that can exist on its own and still retain its physical and chemical properties. So a molecule is the smallest particle of an element that can exist independently or on its own and still retain its physical and chemical property. Now we'll be talking about atomicity. What is atomicity? Did I hear you say city of atoms? That's wrong. Atomicity is the number of atoms in a molecule. Again, atomicity is the number of atoms in a molecule. And that's why molecule can be monoatomic, that is having one atom in a molecule. Example, helium. Diatomic, meaning having two atoms in a molecule. Example, oxygen. Triatomic, having three atoms in a molecule. Example, ozone. Yes, ozone is an allotrope of oxygen. We will see that in our future classes when you'll be seeing what we mean by allotropy. Then when the number of atoms in the molecule is above 3, we can say they are polyatomic molecule. And we have example of sulfur. Rhombic sulfur is S8 and phosphorus is P4. My wonderful student, let's take a look at so many other examples of atomicity of a molecule. As you can see, argon, helium, they are monoatomic because, like I said, they are inert gases. Another element that can exhibit monoatomicity is the metals: aluminium, sodium, potassium, magnesium, name them. Then we have diatomic, example oxygen, hydrogen, nitrogen, bromine, chlorine, and so on and so forth. Remember I said triatomic molecule, we have ozone, and we have tetraatomic molecule, octaatomic molecule. We refer to them as polyatomic molecule. Phosphorus is P4, sulfur is S8. As I round up my class today, my wonderful student, I want to ensure that learning has taken place. So we'll take your short assignment. You see how you can answer these questions and get back to me. I'll be glad to have your responses and know how learning has taken place. If you look at the questions I have above so far, you will see that atomicity of element, match the element with their atomicity. As you can see them here: ozone, phosphorus, sodium, sulfur, hydrogen. Do it and get back to me. Other assignments include define an atom, ion, and molecule. Remember, these are three different definitions. I want to see that from you. State two examples each of atoms, ion, of molecule. They are so numerous. Just give me two examples each. 3. All atoms are made up of three fundamental particles except that, that, that. And tell me reason why that element does not have three fundamental particles. In conclusion, number 4, in a tabular form, differentiate between proton, neutron, and electron. Have a wonderful time as you listen to this video, and you do well to visit my YouTube channel, Philip Maman. If you go on YouTube, just type Philip Maman, you will see several videos in chemistry. And when you play them, I'm sure you will learn. Just in case, you can just tap the subscription button and subscribe to that channel. I'll be glad you did. Thank you very much and see you in my subsequent lesson. Have a blessed day. God bless you.